truth is in the data.
The kinetic energy of a fastball delivered by a major league pitcher. Now, imagine that same energy, approximately 50 joules, concentrated into a single, indivisible subatomic particle, a lone proton, moving so close to the speed of light that its velocity was a string of nines after the decimal point for 23 consecutive digits. This is not a theoretical construct. It is the central piece of evidence in a case that has remained open for decades. The event occurred on the night of October 15, 1991, in the cold, clear darkness of the Utah desert. The primary witness was not a person, but a machine, the high-resolution fly's-eye cosmic ray detector. Its array of 67 mirrors, angled toward the sky, waited silently for a faint trace of ultraviolet light, the telltale signature of a cosmic visitor striking our atmosphere. That night, it saw a ghost. A fleeting cascade of light that signaled the arrival of an impossible messenger. When the peer-reviewed data was finalized, the particle's energy was calculated at an astonishing 3. To the astrophysicists who confirmed the numbers, the result was a flagrant violation of cosmic law. It defied a theoretical speed limit known as the Greisen-Zatsepin-Kuzmin, or GAZK, limit. This isn't just a guideline. It's a fundamental consequence of Einstein's special relativity interacting with the oldest light in the universe. The cosmic microwave background, the faint afterglow of the Big Bang, pervades all of space. For a high-energy particle traveling across millions of light years, this background radiation acts as a thick, energy-sapping fog. Any proton exceeding roughly 5 times 10 to the 19th electron volts should be slowed down by it, its energy stripped away. After a journey of only 160 million light years, a short walk on a cosmic scale. Yet, this particle arrived with over 6 times that energy. It was a fugitive
anomaly.
that should not exist. The event was so profound, so utterly anomalous, it was officially dubbed the "Oh my God" particle. Now, let's open the classified case file and examine the evidence of this cosmic anomaly. The existence of this particle presents us with a stark forensic choice. Either our understanding of high-energy astrophysics is incomplete, or something powerful and unknown is lurking much closer to our galaxy than we ever suspected.
To analyze this case, we must first understand the crime scene.
For forensic astronomy, the scene of the impact is not a crater in the ground, but a transient event high in Earth's atmosphere. Oh my God particle itself never reached the surface. Instead, upon entering the upper stratosphere, it collided with the nucleus of a single, unsuspecting atom of nitrogen or oxygen. In that instant, its monumental kinetic energy was converted into matter and radiation, triggering a cataclysmic chain reaction known as an extensive air shower. This primary collision spawned a cascade of secondary particles, pions, all moving together in a coherent front, a pancake of elementary particles several kilometers wide and racing toward the ground at nearly the speed of light.
Asset.
This is where the forensic instrumentation becomes critical.
Forensic instrumentation.
The fly's eye detector was not designed to see the particles themselves, but to witness their effect on the air. As this shower of particles ripped through the atmosphere, it excited the surrounding nitrogen molecules, forcing them to fluoresce, to emit a faint, ghostly glow in the ultraviolet spectrum. The detector, a collection of meticulously arranged mirrors and 880 highly sensitive photomultipliers. To the instrument, the event appeared as a faint streak of light, a phantom signal drawn across the night sky in mere microseconds. From this single streak, we can extract the entire case file. The process is a masterpiece of scientific deconstruction. First, we determine the energy. The total number of photons collected by the photomultiplier tubes, the integrated brightness of the streak, is directly proportional to the total energy of the particle shower. When we integrated the light curve from the 1991 event, the result was unequivocal, confirming an initial energy that was off the charts, 320 exa-electron volts. This wasn't an instrumental error or a data glitch. The celestial fingerprint was clear and bright. Second, we reconstruct the trajectory. By analyzing the precise timing of when the light struck each individual mirror, we can triangulate the particle's path through the atmosphere with remarkable precision. This gives us its arrival direction, a vector pointing back to its origin in deep space. And it is here that the evidence file goes cold. The trajectory analysis was successful, tracing the particle's path back with an angular resolution of a few degrees.
Constellation Monoceros.
The vector points toward the constellation Monoceros, the unicorn. But when we task our most powerful telescopes to survey this region of the sky, we find nothing. An astronomical void. There are no energetic quasars, no hyperactive radio galaxies, no churning magnetars, no colliding galaxy clusters. None of the high-energy astrophysical objects we know of the usual suspects capable of accelerating particles to even a fraction of this energy are located anywhere near its line of flight for hundreds of millions of light years. The evidence of its impact is undeniable, but its source is a ghost. We have a smoking gun, a ballistic trajectory, but no suspect. An investigation reaches a critical juncture when the physical evidence directly contradicts the established list of suspects. The oh my god particle's trajectory points to a cosmic dead zone, an apparent alibi for the entire known universe.
This forces our forensic inquiry into two distinct,
Initiating
conflicting
parallel
lines of
investigations.
investigation.
The first presumes our suspect list is merely incomplete. The second entertains the possibility that the perpetrator is something that defies all known profiles. Let's begin with the conventional suspects, the known engines of cosmic acceleration. The prime candidate in any ultra-high-energy case is an active galactic nucleus, or AGN. These are the chaotic cores of distant galaxies, where supermassive black holes gorge on surrounding matter and blast out colossal jets of plasma at relativistic speeds. These jets are, in theory, the only objects in the cosmos powerful enough to accelerate a proton to 10 to the 20th electron volts. The problem, as the data file makes painfully clear, is that there are no known AGNs in the direction of the particle's arrival. This leads to a hypothesis. Perhaps the source is a transient event, an AGN that has since shut down, or one that is heavily obscured by cosmic dust. Another possibility is that the particle did originate from a distant, known AGN, but its path was bent by intervening magnetic fields. A charged particle, like a proton, will curve as it travels through a magnetic field. However, a particle with the extreme energy and therefore momentum of the oh my god particle is phenomenally stiff. Its trajectory would barely be deflected by the weak magnetic fields known to exist in the intergalactic medium. To account for the discrepancy, we would need to postulate a vast, undiscovered magnetic structure, coincidentally aligned in just the right way to divert the particle's path from a distant source directly toward us. With no evidence for such a structure, this hypothesis carries little weight in our investigation. The standard model, it seems, is running out of alibis. This is the point where forensic science must push into the unknown. When the usual suspects are cleared, we must consider that the perpetrator belongs to a class we have yet to categorize. We are forced to investigate theories that operate outside the standard model. These are known as exotic or top-down scenarios. Rather than accelerating a particle up to a high energy, these models propose that the particle was born from the decay of something far more massive and mysterious. One leading exotic suspect is the decay of a super-heavy relic particle from the early universe. A particle perhaps 1 billion times more massive than a proton. These hypothetical particles, sometimes linked to the mystery of dark matter, could be silently pervading the cosmos. If one happened to decay within our cosmic neighborhood, within the GZK limit, it could unleash a shower of secondary particles, including a proton with the observed energy. This theory elegantly solves the distance problem, but requires us to believe in a fundamental particle for which we have zero direct evidence. Another suspect is a topological defect in space-time itself. These are theoretical scars left over from the violent phase transitions of the Big Bang, cosmic strings, or domain walls. The collapse of such a structure could, in principle, release particles of unimaginable energy. Finally, we must consider the most profound and disturbing possibility.
What if the law itself is wrong?
The GZK limit is a direct consequence of Einstein's special relativity, a principle known as Lorentz invariance. Some physicists have proposed that at the extreme energy scales of the oh my god particle, this principle might be subtly violated. In this scenario, space-time itself might behave differently, allowing the particle to traverse the cosmic microwave background without losing energy. This would mean the particle could have come from a distant AGN after all, not because its path was bent, but because the cosmic speed limit simply didn't apply to it. This theory places the very foundations of modern physics in the suspect lineup. We are left with a stark choice: an invisible accelerator hiding in a cosmic void, or a fundamental revision of the laws of nature. Our investigation concludes at a scientific crossroads. The evidence for the oh my god particle, its energy, its trajectory, the signature of its impact, is. Yet every theory advanced to explain its origin leads to an uncomfortable conclusion. The conventional suspects, the AGNs and other cosmic accelerators, require us to accept the existence of a perfectly hidden source, or a magnetic field configuration for which we have no evidence. The exotic suspects, from decaying dark matter to cracks in space-time, demand a belief in new physics. A radical departure from the standard model that has guided us for half a century. This case file, therefore, must be officially classified as unsolved. The phenomenon of ultra-high-energy cosmic rays is not in doubt. Experiments that followed the fly's eye, chief among them the vast Pierre Auger Observatory in Argentina, have confirmed the existence of particles that press against the GZK limit. Yet the 1991 event remains the most extreme outlier, a singular challenge that has not been equaled. It serves as a stark, indelible reminder that our cosmic neighborhood may be far more complex. The oh my god particle was not a failure of detection, but a profound and humbling success. It revealed a genuine anomaly in the fabric of reality, a clue that points toward a deeper understanding of the universe that still lies just beyond our grasp. The investigation continues. And so, the dossier on this impossible messenger from the void remains open on our desk. A testament to the beautiful and often bewildering nature of cosmic inquiry. It teaches us that sometimes the most significant discoveries are not the ones that provide clear answers, but those that leave us with far more profound and illuminating questions, pushing the very boundaries of our exploration into the silent, sprawling darkness.